Welcome. Today, we have an interesting topic to discuss, the bounded buffer problem. Now, you might be wondering, what is the bounded buffer problem? Don't worry, we've got you covered. In this video, we'll teach you the basics of the bounded buffer problem, provide an example and conclude with some key takeaways. So let's dive right in. The bounded buffer problem is a classic synchronization problem in computer science. It involves coordinating multiple processes or threads that share a fixed size buffer. The goal is to ensure that producers can add items to the buffer without overflowing it, and consumers can retrieve items without accessing an empty buffer. To make these topics easier to understand, I am about to use the game Among Us
Hell no, man. What the fuck, man?
as an analog so that it will be easy to see what is going on. For this part, the crewmates will act as producers that pass down tasks into buffer. The crewmates have a set of tasks they need to complete to ensure the ship's safety. The imposter
Among Us!
will act as a consumer that will consume tasks from the buffer. The imposter will be trying to sabotage their progress by consuming tasks given by crewmates. The task board represents the bounded buffer, with limited space to store tasks. Each crewmate
Among Us!
can only place a task on the board if there is enough space available. Similarly, imposters can only remove tasks if there are tasks present on the board. As crewmates complete their tasks, imposters can remove tasks from the task board to create chaos and cast suspicion on innocent crewmates. But if the board is empty, they cannot remove any tasks, forcing them to wait for new tasks to be added. Upon receiving the notification, the imposter can now remove a task from the task board, causing confusion and raising suspicion among the crewmates. On the other hand, if the board is full, they must wait until there's space available. This prevents the board from overflowing. To summarize the bounded buffer problem, a fixed size buffer is shared between producers and consumers. Producers can only add items to the buffer if there is space available. Consumers can only retrieve items from the buffer if there are items present. Both producers and consumers may need to wait if the buffer is full or empty, respectively. And there you have it. You've learned the basics of the bounded buffer problem, with an exciting example. Remember, the bounded buffer problem is just one of many synchronization problems encountered in computer science and concurrent programming. If you'd like to explore more about this topic and dive deeper into the world of synchronization, I recommend checking out the following resources. Feel free to continue your journey and expand your knowledge. Thank you for watching, and until next time, happy learning.
Among Us!